Alright, there were a few students who were having a difficult time with this is factoring again, but this technique is factoring by grouping. So let's run through a problem here. Remember, we talked about in class one of the key things we notice when we want to use this technique, or what triggers us to think about this, is a problem that we're trying to factor that has 4 terms in it, okay, which this one does. And what you do is you just look for 2 terms that have similarities and another 2 terms that have similarities. So for example, the first term has an 8, an m, and an n, and the second term has an m and a 4. So they both have m's in them, and they're both divisible by 4. So there's a similarity between those two. And the 6n and the 3 are both divisible by 3, so there's a similarity between those two. Once you've found a pair that 2 pairs that have similarities like that, you group them. So I'm going to group the 8mn and the 4n together, and I'm going to group the 6n and the 3 together. Then I'm going to pull out that common part of them. So I'm going to take a 4 and an m out of the 8mn, which leaves 2n left over, and oops, I dropped my hump on my m there. And I'm going to take the 4m out of 4m, which leaves me a factor of 1. And you always just recheck in your head really quick. If you redistribute, do you get what you started with up there in red? 4m times 2n is 8mn, and 4m times 1 is 4m. So I know this factorization for that first grouping is correct. Do the same thing with my second grouping. I say, okay, what do you have in common? They had a 3 in common. So I pull that out. I check it and go, that's 6n plus 3, so I've pulled it out correctly. Now I kind of step back and I look at the 2 terms. Here's my first term, it's just in factored form. Here's my second term in factored form. What we mean by factored form is that the first term is written as 4m, a factor, times 2n plus 1. And the second term is written as 3, a factor, times 2n plus 1. And there is a common factor in these 2 big pink groups. And that common factor is both of them have 2n plus 1 in them. So I grab that common factor and I'm going to pull it out of this first term. So I take this 2n plus 1, I pull it out in front, and I'm left with a 4m. And then I take the 2n plus 1 and it's pulled out of that one, and I'm left with 3. And I'm done. I have now got it written as a product of 2 binomials. This thing at the very top, this polynomial, is factored. I'm going to just show you a couple things here. First of all, let's look at this step right here. A lot of students have a hard time going from that step to this step. I'm going to make a little substitution to make it easier. I'm going to make a variable. I'm going to call it x. And I'm going to let x equal 2n plus 1. Okay? And when I do that, it allows me to rewrite this expression. And I'm going to rewrite it as, there's the 4m. I'm replacing 2m minus 1, or 2n plus 1, with the x that it equals, plus 3, the 3 right here, and I'm replacing 2n plus 1 with the x. Okay? So this boxed-in expression and this new expression are the same thing, except I've just substituted out x with, or 2n plus 1 with an x. And if I were to say factor this new expression down here, all of my students, all of you would go, well, they have an x in common, and I'm left with 4m plus 3. Okay? That's exactly what I did over here. Here's the 4n plus 3, 4m plus 3, and the 4m plus 3. And I pulled out this x. Well, over here I pulled out 2m plus 1. That's what x is equal to. I could even do a substitution and say, well, x is really 2n plus 1. Okay? So this indeed is the correct way to factor out 2n plus 1 in that expression. So our final answer, 2n plus 1 times n plus 3, if I were to check that and distribute 2n, I get 8 nm, I get 6n, I distribute the 1, I get 4m, and distribute the 1, I get 3. So there's 8nm, that's this guy. I get 4m, that's this guy at the top. 6n, that's this guy, and the 3. So that is the correct factorization, and your final answer is just that 2n plus 1 times 4m plus 3. Hope that helps. I'm going to throw one more on here really quick. I'll do less talking and just let you watch the technique. This is problem, it looks like 208. 3xy minus 4x minus 15y plus 20. So with less talking, I'm going to group the first two. They have at least an x in common. I'm going to group the second pair, negative 15y and 20. Notice I have to keep the sign with the negative 15y. That means I've got to put a plus sign in between those. What I'm actually doing is kind of treating it as plus a negative 15y plus 20. I'm going to factor out my GCF. These both have an x in them. And these, looks like I can pull out a 5, but I'm going to pull out a negative 5 because I want positive 3y when I get done. So I pull out a negative 5, and I'm left with 3y minus 4. My common factor, 3y minus 4, I pull that out, and in my first term I'm left with this x, and in my second term I'm left with this negative 5, and the problem is complete.